My name is Shan Gupta, and I'm here to talk about database. I'm a principal solution architect with OCI. I've been here for 2 years, and I've been doing databases for about 22 years. So great discussion on the availability and performance. And in the fullness of time, I'm going to go a little bit faster, so I have the time for the next speaker. Feel free to stop me if there is any question. So today's challenge that we are talking about on-premise, what are the challenges, and why move to OCI and why OCI. So let me try it. Can I try it? So the main challenge today in the on-premise is slow infrastructure. The hardware is getting old. Hardware refresh is not that easy on-premise, and it takes time and effort. In addition to that, data center, managing the data center is very complex thing. You have to hire tons of people, and you have to work in harmony to make sure you are reaching the same availability, same performance that you are expecting on your business. So how do we solve that? This discussion is mostly focused on the database. So I'm trying to solve these two problems, the slow infrastructure and the data center complexity on the database side of it. What we offer on OCI, there are two differentiators compared to other cloud provider and compared to the on-premise. We don't offer anything today that you can't do on-premise, but the differentiator is how much time does it take. Like for Exadata, provisioning Exadata on-premise takes 2 weeks today at the minimum. Here you can do it in 30 minutes. That's the main differentiator. So what we offer here is we start from a single core, one core VM. You can run your entire Oracle database on a one core VM, and you can expand it up to 336 CPU on Exadata. So you have a huge range of choice, starting from virtual machine that comes in different shape, 1, 2, 4, 8, 16, 24 CPU. And after that, you can go up to bare metal node, where you can start from 36 node, 36 CPU, or up to 52 cores. After that, you can go into 2 rack node, where you can expand up to 48 CPU. After that, you can go up to the Exadata, where you can expand up to 336 CPU. That's a huge amount of horsepower that you have it on the cloud, and you can provision this horsepower in a matter of few minutes. That's the main differentiator that we offer on OCI. Oracle offers 2-node RAT. How many of us here knows about Oracle RAT solution, real application cluster? Okay. So 2-node RAT is highly popular in the industry ever since it came out. We announced it from 9i onwards. For it's about 12 years, I think, that it has been out, and it is the most widely used configuration for the production workload. We are the only cloud provider in the industry who offer certified, Oracle certified 2-node RAT on the cloud. We offer full feature 2-node RAT. It's not a limited feature. We offer the STHAN IP. You still have to connect to only one IP address that will float between the 2 nodes. So when one node fails, your services automatically fail over to the other node. The database fails over in a matter of seconds. One node fails, your application, all it has to do is reconnect to the database, and this time automatically the connection will land on the surviving node. You don't have to do any config changes. There is no outage required, just a reconnect. Availability and DR. When you talk about database, DR is very important. When you talk about database, availability is very important. We offer fully supported, fully certified data guard on OCI. This is something today we offer at a regional level. You can deploy your database with a DR, data guard built in between the 2 ADs or between the 3 ADs, if you like, to have your DR ready to go. Data guard within the same AD, you can build the DR within the same AD if you are looking for a 0 data loss. Your hardware fails, you flip over to the other database on the same AD or in another AD. So you can pretty much build a 0 data loss configuration for your database. You never have to worry about losing your data.
Can I do this between on-prem and OCI?
You can do that, yes. But the synchronization, how fast you will be able to replicate the data on OCI, it will depend on where your data center is located and the latency is involved with that. But yeah, many customers are deploying their DR on OCI for that single reason, because they don't have access to 3 data center or 2 data center on premise. They are limited to what they have, and now they are building their DR on OCI.
And then presumably that's an onboarding. Eventually they go, you know what, I'll flip
That's
that.
one step you do to migrate your databases from on-premise to OCI. You build a data there on OCI, and when you take a small outage, and you flip your database over here. Yes.
Who supports the recovery?
As opposed to recovery?
Who supports the recovery? Is that the customer's responsibility?
Recovery of what?
We're using DataGuard as a backup.
Yeah, so you configure the fast start failover. You configure the data guard in maximum performance or maximum availability mode, and then you manage how far behind your data guard is. And at the time of cutover, you just take a small outage on the primary side, bring over the last few minutes of changes, and do a cutover.
But that's all entirely automated then?
Yes. You can fully automate it. Actually, that's a very popular DR solution on premise today as well, and we offer it on the cloud.
What happens if you want to go back a little bit in time because you've got a corruption, you don't really want to go back to that replica fully? Can you sort of get additional support to allow you to be a bit more?
So data guard is a block copy. So if there is a corruption on the primary, most of the time it doesn't flow into the standby database, the DR. But if it's a logical corruption that we are talking about, like you made a delete in the database, it will flow into data guard. So you have to define your RTO, RPO, and accordingly you can put the data guard behind few minutes. So let's say you wanna handle a 15 minutes of recovery. If there is a user error on the primary side, 15 minutes is the allowed time, and then you can keep your data guard behind on that time. It's all configurable in the data guard itself.
Okay.
In addition to that, you can also do daisy chain configuration. So you build a data guard within a single AD, so you are protected against the hardware failure. And from that single AD, you shift it to another AD or to another region to get a true DR. So let's say you want, it's a financial application, and you want to drive a true DR with a geographical different region, you can build that using the data guard.
Now, all of this configuration of DataGuard is the responsibility of the customer?
So we offer data guard as a service today.
Okay.
Where we do the basics of it, and after that customer takes over, and they manage it from there.
Okay, so you do the initial setup and configuration, and then it becomes the customer's responsibility?
Yes.
Is there a fully managed DataGuard solution?
It's coming, it's in the roadmap. We are coming with a different mode, and where you can say that, okay, this is how I want to build my data guard, and OCI will build it for you. Today, we allow you to pick the location of your data guard, so you can pick another host in the same AD or another AD within a region. Any other question? So now I'll get into differentiator. What's different on OCI? So this is how your database server looks today on premise. You have a bunch of hardware at the bottom, like storage, CPU, and memory. And after that, the DBA will install software stack. You will start with the operating system, then you install the grid infrastructure, then you set up your ASM, you throw out your disk, and then after that you build your database. All of this is done on premise, and you don't have to do it anymore on the OCI. We do it for you. Now deploying that database on OCI is as simple as making certain choices. You just need to tell us how big your database is, because you know your workload better than anybody else. We ask you what kind of hardware you want. So first of all, we will ask you how big your shape should be. So it should be 4 CPU, 8 CPU, 16 CPU. That's the first choice you will make. After that, we will say what database version. We support 11G-R2, 12C-R1, and 18C now. 18C is the latest database that we offered, that we announced in December, and it is fully supported on OCI today.
Silly question, but is there support for any other databases than Oracle?
Yes. So
Not so silly.
other than Oracle, we offer you a wide range of infrastructure that we talk about storage, we talk about networking. On this infrastructure, you can run any database you want. We have many customers running Mongo on us, many customers running Cassandra on us. It's fully supported. We provide you the modern infrastructure where you can run any database.
So what you're talking about is just like a bare metal.
IaaS, infrastructure as a
In which
service.
case, you can run whatever you want. You can run your own, roll your own.
But can you run different DBMS on the database cloud service, or is it just Oracle? So could I?
We also offer MySQL as a managed service.
Microphone.
Yeah, we also offer MySQL as a database service. But in terms of like SQL Server, for example, we don't offer a service for that, right?
Is there any plans to add Postgres or heaven forbid, MS SQL Server?
So we support SQL Server running in our environment, but we don't offer a managed service for SQL Server currently. Yeah.
Is this the only hosted database as a service as part of the Oracle Cloud stack? Like, does it show up somewhere else in the portfolio of services all the way up to the SaaS-based offerings?
So this is
Or is
offered
this
as
the only?
it's offered as a platform as a service, PaaS.
It is.
And it is offered under the same OCI umbrella, under the same web console. So I'm going to go into the demo in a couple minutes.
So what's the difference between that? What's offered here versus database as a service as part of the PaaS offering?
It's the same thing.
It's the same thing.
Same thing, yeah.
Okay. Okay.
Except it runs on the OCI infrastructure on the back end.
Both of
Same
them do.
Yeah.
Same, both.
Yeah.
Yes.
Okay. Okay.
So after you choose your hardware, what shape you want, you will choose the database edition, 11G or 12C. And we are not limiting you to run just 11G or 12C. If you have a legacy version running on premise, after the database server is provisioned, you are happy to, you can bring your own 10G 9i database version, install it on the server, and then you can run your database on OCI as well. After that, we offer you the choice to bring your own license, or you can buy the license included model where the license is built into the prices. So I'm not going to go into the actual launch process. The launching the database server is similar to what Lee showed you when you want to launch a compute server. So this is the same console that Lee was showing earlier, and launching the database experience is pretty much the same. You choose your name, the availability domain. We let you decide where you want to launch your database server. After that, you choose the database versions. And then there are a couple more questions related to database that we will ask you. So launching experience doesn't change for you. So I will show you how you can do the same thing using the CLI. So this is an example of Python that I wrote in launching the database. And all those choices that you made on the web console, you just pass it as a parameter. It's a standard REST API. You pass certain values, you pass your values, and then you just fire it up. Everything that you do on the web console today is API driven. So behind the scene also, this is firing the same API.
Does OCI have SDKs for
Yes.
interacting with the API?
Yes, we do have SDK in Ruby, Java, Python, and Perl. So after that, I just need to So here I just launched a database server.
Does the Terraform provider support the database?
It does.
Yeah.
So you can launch a database using the Terraform also and build a fully automated environment for you. So this is the database server that I just provisioned. It is provisioning the 4-core VM. That's the shape we have here. And certain values. So now what are the differences? You can build the same database server on premise. Here, sure, you are saving some time building the database. But again, the differentiator here in OCI is we allow you to bring all your tools that you are using on premise. We give you full access to the database server as a root level, as a DBA level, as a sysDBA level. So your engineering team, your DBA team don't have to relearn the platform. They can do exactly what they have been doing on premise. Now they can do it on OCI. They don't need to redevelop the new tool. They don't have to rewrite their code. They can follow the same process that they have. It's a totally seamless process for them. most of the cloud provider, they don't let you do that. You will not have access to the database log. You will not have access to DBA log. You will not be able to see the infrastructure log. You will not see what the operating system errors are. And that's what we allow it on the OCI, where you can bring your own tools onto the OCI. So now I'm going to dive into the next topic. I'm going to skip the patching because we are running out of time. The coolest feature that we offer on DBAS is scaling, the CPU scaling that we offer. And I call it as a Black Friday night, because most of the time when you plan your hardware, you plan it for your Black Friday. That is the top load that you want to support from the business side. Now I understand Black Friday does not apply to other industry except the retail, but again, for database world, there is a Black Friday every night. When the batch report runs, when the backup runs, that's the Black Friday for my database, and it happens every night, most likely after 9 p.m. So what happens at 9 p.m.? You are out of CPU. You don't have any more CPU. And then after the batch jobs finishes, you are back to the underutilized hardware where you are not consuming all the CPU. Now talk about hardware planning. When you buy your hardware on premise, you plan it for next 3 years. That's the typical life of a hardware. That's how often most of the company refresh their hardware. So what they do is they plan their application size in, and they say, okay, what is the growth rate that I should expect on this business? Now what happens is first year volume becomes normal for next year, and then you plan for next 3 year hardware. So today you end up buying the hardware that you will need down the line after 3 years. And on top of that, there are a lot of variables that you are just assuming. You are assuming there is going to be a 20% growth in the service. You are assuming that there will be 200 more users or 400% more user down the line. So what you are predicting is the workload that is very, very it depends on so many variables that are unknown to you. And that's why predicting the future is very hard. That's where OCI come into picture. What we offer you is dynamic scaling, so you can add more CPU on demand, and you can actually reduce it down the CPU when you don't need it. All of these things you are paying by hour. So you pay the database service by hour, and you can scale up when you want, and you can scale down when you want.
So what do you mean you can scale up? In what sense when you've got a physical server? Right.
So when you launch a database on bare metal shape, the bare metal shape will come with either 36 CPU core or 52, depending on what generation of hardware you chose. And on this bare metal server, you will have an option to run database with only 2 CPU enabled, or in multiple of 2, up to 36 or 52.
Okay, so you're giving people hardware that's heavily overspec'd.
Yes.
On the assumption that they might, in the future, at some stage upgrade.
Right. So that's the scalability feature that we offer on the database, and that's what helps the DBA community when they are running into Black Friday situation. 9 p.m. they can fire up more CPU. At 6 a.m. they can lower down the CPU.
But isn't that sort of not very cost effective for you though, because you're committing hardware resources to customers who might not even use it?
Well, you haven't seen the price yet.
Oh, well, I haven't seen the price yet, and I agree, you're right. I might be paying for it already. That might be true.
You can scale up to this thing you've already paid for.
Yeah, I mean, no, but
so
someone's paying for it.
You have to worry about licenses.
That's the point. That's the point I'm trying to make. When you run a database server, 90% of the cost of the host goes to the licensing. Here, when you enable disable CPU, you are actually buying the licenses by hour, and you have the flexibility to choose how many licenses you want to enable at any time of the day. That's the main advantage. So you're right, you're paying for the infrastructure, but the licensing cost, which is the 90% of your database server, is actually helping you save money. So I'll jump into a small demo, and then I will hand it over to Farhan. So I don't know, do you know anything about this Spinbench tool that I am planning to use here? It's an artificial load generator. It generates the workload on the database, and you have a lot of ways to configure the different parameters. So I have provisioned a bare metal server and a database running on it. Currently, it is configured to run on 36 CPU core, and I'm going to fire up a workload on it. So I have configured 1,000 users, and I'm just starting the workload on it. So what it does, it already has some data loaded into the database, and after that, it will fire a mix of read and write workload on the database. Here on the right, you will see the performance matrix. It will show you how many transactions we are performing per minute. So we just fired up the load. It is logged into 1,000 users, and now it's running some insert, update, deletes on the database and a lot of read activities. So as you can see, the load is still warming up. It's doing about 28,000 transactions per minute. I'll give it 10 seconds to settle down, then the load will be stable. Load is still warming up. It's doing a lot of TPM, 42,000, 43,000. The middle graph is showing the transactions per second, TPS, and the third graph is showing the latencies, what the latencies are for these transactions. Here I have one node database running here, and the database version is 12.2. That's the database version that I'm running. So as we see, the load is stable now. Now it is doing about 65,000 CPU, 65,000 TPS, and this is with the 1,000 user base. Now this is a healthy state. This is the normal state that you want your database. Now let's say you have a weekend coming up and you want to lower down your usage. You can dynamically change the CPU, and you can actually reduce the number of CPU, or you can increment the CPU without taking any outage. Essentially, you don't even have to bounce the database. You don't have to bounce the server. It's a fully online, non-intrusive activity. So from 36, I'm going to go down to 2 CPU. So the bare minimum on a bare metal server is 2 CPU, and up to 36 or up to 52 CPU. So now the server will go through a small change. It's a configuration change on the back end, and we will see the difference right here.
So this is a bare metal server that has
36 core on it.
36 cores in it.
Yes.
And you're only allocating 2.
So I am disabling the 34 CPU right now from 36 to 2 CPU, and they will be disabled on the host side.
From a cost perspective, am I now only being charged for 2
From the license
CPUs?
perspective, yes. From the database license, you
Database license, yes. What about the...
So when you
virtual
provision a
machine
bare
or the
metal
bare
server
metal
database, the price is fixed regardless of how many CPU you enable with,
Okay.
and the license prices will vary.
So you're saying there's 2 costs? There's the license cost and then also the service cost?
No, so when you buy the compute on infrastructure side of it, you pay different price. When you buy the CPU on the DBaaS side, database cloud service side, the prices are different, and it includes the infrastructure cost of 36 CPU.
Okay, but what about the database license cost?
License fees depends on how many CPUs are enabled, and it is paid per hour.
So there's still 2 costs.
Right.
There's the
Yes.
whatever service cost plus whatever database license cost.
So I'll get to it one second. So what I'm trying to show here, you see the downgrade of the TPM, and you see the increase in the latency. So when we reduce the number of CPU, the throughput of the database server is dropping, and the latencies are increasing. And I did it dynamically on the fly without taking any outage. So now coming back to the license version. So when you buy this database license, database server, the prices are going by the hour, and they are going by how many CPUs are enabled at any time of the hour.
Okay.
So you enable 4 CPU, you pay for the 4 CPU price for the database server.
And that includes the database license.
It depends on which model you chose. If you say bring your own license, then we assume that you have the license
Sure.
for 4 CPU.
No, that makes sense.
And if not, if license included prices, then yes, the license prices are included in there.
And that can be driven by API.
It's all fully driven by API. Just like I launched the new database server, you can change the CPU scaling up and down using the APIs.
Do you guys have a concept of auto scaling for the database?
You can monitor it using the shell script. Since we don't have access to your bare metal, we offer you a true isolated environment. You have to monitor the health of your database, and you can fire up the API to go up and down on the CPU. So auto scaling is built in using the API. We have only 10 minutes, so I'm not gonna finish my. But these are the different shapes that we offer on OCI for database. You can start from 1 CPU minimum up to 336 of a CPU. So there is a huge use cases for it. You can run your dev test production, and you can run your warehouse also on OCI using this larger shape of the CPU.